Okay, so we have a box, and it's going to have a mass of 35 kilograms. So this is what the problem's going to tell you. It has a mass of 35 kilograms. It also is going to require a force of 900 newtons in order to make it move. Okay, so it's going to be at rest. In order to make it move, it's going to be 900 newtons is the force to make it move. So force to move is 900 newtons. We know the box is at rest. So we know VI is 0 meters per second. It will also tell us that our unknown is the coefficient of static friction. So we're trying to find the static friction. So we need to know the most amount of force that is used to prevent it from moving. So if it requires 900 newtons to move it, we can assume at 899 newtons, so 1 newton less, that it would no longer be moving. It would be at rest. So if it requires 900 newtons to move, we're just going to subtract 1 from it, and that's going to give us the force of static friction, because that means it's at rest. If you were to push with this force, it would not be moving. So that's probably one of the harder things to know about this problem, is just knowing that the force is static. Essentially, if you do set it equal to 900, that's fine. You'll still get like the same answer. It might just be off by 1/100 of a decimal or something like that. So what we're going to do with this box, first thing I'm going to do is, step 1 is force diagram. So force of gravity and then opposing force of gravity is going to be your force normal. This will just help us solve everything we need to know. So our unknowns are going to be Fg and force normal. The reason why is I like to start with Fg and then go counterclockwise. Notice we already have force of static friction. We got that from it telling us it requires 900 newtons in order to move it at all. So our equation for Fg, we're going to have Fg equals the mass and the acceleration in the y direction. Notice gravity is going to be accelerating it, so one of our givens, AY, negative 9.81 meters per second squared. So to get Fg, we're going to take 35 kilos, we're going to multiply it by negative 9.81 meters per second squared. You'll get 343.35 newtons. And it'll be negative because it's going downward. Okay? So now we got Fg. To get force normal, okay, is it going to move in the y direction, this box? If you're pushing it horizontally, it definitely should not move in the y direction. It shouldn't go up. It should only be moving left and right. So the net force in the y direction has to equal 0. Okay, with us knowing that, we only have 2 forces acting on it in the y direction. We have a force of gravity and a force normal. Well, we already know that the force of gravity is negative 343.35. So to make the net force of these two to 0, the force normal is going to have to equal this number but be opposite in direction. So force normal is going to equal 343.35 newtons, but it's going to be positive because it's going upward. Now that we have Fg, we have Fn. Next step, we can solve for coefficient of static friction. So equation I'm going to use, mu s equals force of static over force normal. Now we just multiply by both sides. Sorry, don't multiply by both sides. It's already solving for mu s. All we're going to do is plug it in. So force of static, we have 899 newtons. Remember, it's going left, so you can make it negative, although mu s doesn't really have direction. It's just a ratio. So if you leave off the negative, that's fine. Because it actually shouldn't have one, but if you put it on, don't worry about it, I won't count it wrong. Then you divide it by your force normal, which is 343.35 newtons. Your mu s should be a value of 2.6, and it will not have any units, so that would be your answer.